we are with the Chapter 4 review. So we'll start here with number 1, which asks us to find the correct end behavior of the diagram for the given polynomial function. Well, you can always graph this in your y-equal and take a look at what's going on with the function as far as the ends. But the way that you really tell is you look at your leading coefficient and whether it's, that's not pointed the right spot right there, whether it's positive or negative. Well, this one's negative, which tells us that on the right it's going to be going down because the sign of your very first term tells you what it's doing on the right. So if it was positive, it would be going up on the right. If it was negative, it's going down on the right. So this one's negative, down on the right. And then you look at the degree. The degree of this polynomial is 5. When the degree is odd, your left side and your right side are doing opposite things. When your degree is even, they're doing the same thing. So since this is a 5, which is an odd number, that means it has to be doing different things. So since it's down on the right, it would have to be up on the left. So my answer is B. If it had been even, they'd be doing the same thing. The leading term tells you what it's doing on the right, and then the degree tells you whether it's the same on the left or the opposite on the left. Number 2, find the zeros of this polynomial function and state the multiplicity of each. Well, 3 is just a number out here. There is no variable. 3 will never equal to 0, so we don't really even have to worry about that. Then I've got x plus 6 twice. So I'm going to set x plus 6 equal to 0, and I solve that, and I get x equals negative 6. And that's got a multiplicity of 2 because there's a to the second power. And then I've got x minus 6 is a 0, and so I solve that, and I get x equals 6, and that has a multiplicity of 3. So my zeros are negative 6, multiplicity of 2, and positive 6, multiplicity of 3. My answer for number 2 is B. Number 3. A formula relating an athlete's vertical leap in inches to hang time in seconds is V equals 48t squared. A professional basketball player has a vertical leap of 30 inches. What is his hang time? Round your answer to the nearest something. Hang on. To the nearest tenth of a second. So it's V equals 48t squared. We know that V is going to be 30. We're trying to find t. So I'm going to divide by 48. So over here on the calculator, I want to do 30 divided by 48. And that gives me 0.625. So I'd have 0.625 equals t squared, and then I'd want to square root it. Now, obviously, there's a positive and a negative square root, but because this is talking about time, we're only going to worry about the positive square root. So I just want to do the square root of 0.625, and I get 0.79. So they said round to the nearest tenth of a second, so that's going to be 8 tenths of a second. So 0.8 seconds, my answer would be C. In number 4, we have a stone that's thrown downward with an initial velocity of 19.6 meters per second. That's where the 19.6 comes from in the equation. It will travel a distance of s meters, where s equals 4.9 t squared. The 4.9 has to do with gravity, and then the 19.6 is your initial velocity. But they go ahead and write the equation for us. If a stone is thrown downward at 19.6 meters per second from a height of 294, so the height is s, how long will it take the stone to hit the ground? So 294 equals 4.9 t squared plus 19.6 t. Well, to solve this, I'm going to set it equal to 0. So subtract 294, and then I'm going to solve this. I think that I will use the calculator. You can use quadratic formula here, but I'm going to use the calculator. I think it might be a little bit faster. Y equals 4.9x squared plus 19.6x minus 294. Wrong number. 294. Let's see here where it's going to cross. It goes up, and it's going to come down over here somewhere. Okay, right there. So, looks like about 1, 2, 3, 4, 5, 6 seconds. So let's check second trace. What's my 0? There's obviously one over there on the left side, but since that would be time negative, I'm not really worried about that. Um, I'm worrying about this one. Looks like I'm getting pretty close here. So I'm going to have a left bound right there. Then I'll move over and get a right bound. And I'll ask it, where is that 0? It's when x is 6. So after 6 seconds, that's how long it would take to hit the ground. All right, good job. That's easy. You could also do quadratic formula and you'll get 6 seconds. All right, here, they want us to use the intermediate value theorem to determine which of the statements below is true. If A is 1 and B is 2, they want us to figure out, is there going to be a real 0 between them? All right, so let me kind of explain what would happen. Let's say I plug in 1 and I get a negative number, and I plug in 2 and I get a negative number. Is there a real 0 between them? Well, I don't know. There could be. It could go up and back down. There could be two real zeros between them, or if this is a negative and this is negative, it may just go right here between these two and never hit 0 in between them. So I don't know if they're both negative or if they're both positive. But if one of the numbers is negative and one of the numbers is positive, then there has to be a real 0 between those two because these functions are continuous. So in order to get from a negative number to a positive or from a positive to a negative, it would have to cross the x-axis. So what I'm going to do is I'm going to take this function, I'm going to plug in 1 and 2 and see what I get. So 10x to the third, I'm going to type it in here, I'll be a little bit quicker, 10x to the third minus 4x squared. Whoops, I'm still up there at the top. I always do that, don't I? Minus 4x squared minus 9x minus 2. And they want me to test 1 and 2, I believe. So A is going to equal 1 and B is going to equal 2. So on my table, all right, when x is 1, whoops, I've got it set up for ask instead of auto, don't I? So I go to second window to change that back to auto so that my table's just counting by ones. So when x is 1, I get -5. And when x is 2, I guess I'll stop moving. Went too far. When x is 1, I get -5. And when x is 2, I get 44. So if at 1, I'm at -5 down here, and at 2, I'm at 44 way up here, is there a 0 between them? There would have to be. So f of 1 and f of 2 have opposite signs. Therefore, the function f has a real 0 between 1 and 2. That's going to be my answer. F of 1 and f2 have the same sign. That's not true. One's positive, one negative. Have the same sign? Nope. Let's just make sure this one's not right. F of 1 and f2 have opposite signs. That's true. Therefore, the function does not have a real 0. That part's not true. So because they have opposite sides, it has a real 0 between them. All right, number 6, use synthetic division to find the quotient and the remainder. So I have x cubed minus x squared plus 3 divided by x plus 2. So on the outside, I find the 0 of x plus 2 set equal to 0, so it's going to be a -2 on the outside. And then I'm going to write the coefficients of my terms up here. So 1x cubed, -1x squared. There's not an x, so I've got to put a 0 to hold the place. We talked about that in class today. And then 3 is my constant. So bring down the first number, that's a 1. -2 times 1 is -2, add. -2 times -3 is 6, add. -2 times 6 is -12, and add. So my answer would be x squared minus 3x plus 6 with a remainder of -9. And sometimes they'll write it as remainder, sometimes they'll write it as a fraction over the divisor, but my answer is remainder of -9, and there it is, A. All right, let me do a couple more synthetic division and then we'll pause for the next video. All right, on the outside I'm going to put -1, and then underneath I'm going to put 2x cubed, 3x squared, 4x, and -10. Bring down the 2. -1 times 2 is -2. Add. 3 plus -2 is 1. -1 times 1 is -1. 4 plus -1 is 3. -1 times 3 is -3. And add, and you get -13. So it's going to be 2x squared plus x plus 3 with a remainder of -13. So my answer is B. And then number 8. On the outside, I'm going to put a positive 1, and then I'm going to put 2 x to the 5th, negative 1 x to the 4th. There's not an x cubed, so I'm going to put a 0 there. 3x squared, negative 1x, and 5. Bring down the 2. 1 times 2 is 2, and add, you get 1. 1 times 1 is 1, and add, you get 1. 1 times 1 is 1, add, you get 4. 1 times 4 is 4, and add, you get 3. 1 times 3 is 3, add, you get a remainder of 8. So it starts with 2x to the 4th plus x cubed plus x squared plus 4x plus 3 with a remainder of 8. My answer is C. All right, I'm going to pause it right there, and we'll pick back up with number 9.